All right, a couple more of the logarithmic ones. Let's look at, it was problem number 70 on the guided outline. All right, let me go ahead and get a new page here. Get started on a fresh page. Okay. All right. So on this one, I'm being asked to use logarithmic um, differentiation. So I'm going to do natural log of y on both sides. And let's go ahead also and remember it works best when you have things written with fractional exponents. In fact, you may want to do that up here first. You know, that would be equal to x squared times x plus 2, all raised to the 1/2 power. Okay. And it might help too for you to remember that if this is times, then you can raise each of those by doing x squared raised to the 1/2. That would be x squared to the 1/2 times x plus 2 to the 1/2. And then this would become x, and this would be x plus 2 raised to the 1/2 power. Okay? So I can do all of that if I wanted to first. But you know what? If I were going to do that and nobody told me I had to use logarithmic differentiation, then I just wouldn't. That right there would not be a very tough problem to do the normal way. You would just wind up using the product rule, and you'd have a little power rule mixed in. Okay? But I'm going to go ahead and do the natural log. And you may have, I would still personally have gone to here before I did the natural log of both sides. So if I do the natural log of both sides from maybe back a step, in case you didn't think to do that, I could. And if I natural log both sides at this point here, goes there and then has the 1/2 power. Then I could use a property of logarithms to bring that 1/2 down. Okay. And then do you notice how I have a product here? So then inside here, I could have the natural log of x squared plus the natural log of x plus 2. Okay. All right. And then right here, where I have a squared, I could bring that down. I'd have 2 natural log of x. And then don't separate this. This is a plus, so you can't really pull that apart. You're going to have to leave that inside. All right. So I could do all of that and then just work on taking the derivative of both sides. So let me bring that lny back in. Remember, none of this is doing the derivative yet. This is just using the log properties. Now I'm going to start doing the derivative. So the derivative of an ln is 1 over your input, and then I have to do the derivative of the inside function. Okay, this is a constant, so I can just bring it down. Then I'm going to do the derivative term by term inside here. So the derivative of, and then 2 is constant, so I can bring it down. The derivative of natural log is 1 over my input, and then the inside function's derivative would just have been 1, so you don't really need to write that. Then here, 1 over my input, and then the derivative of the inside is really just 1. Okay? All right, and then I might clean up this a little bit just so I can see what I got. So inside here, I have a 2 over x plus a 1 over x plus 2. Okay, over here, I still have that 1 over y times y prime. All right, I'd like to distribute that 1/2 to both. Okay, let me go ahead and write it next to both so you can see what happens to that 1/2 in that first spot. Okay, see how that would become just 1 over x, and then here I have plus 1 over 2 times x plus 2. Okay. All right, and I still have my 1 over y times y prime. All right, so then if I multiply both sides by y, okay, then that knocks out the 1 over y and leaves me the first derivative, which is what my whole goal was, right? And then right there where the y is, I'm going to put what I had originally, but I'm going to use the, put that raised to the 1/2 power on it. All right, so that's the y, and then I still have this 1 over x plus 1 over 2 times x plus 2. Okay. All right, so that's pretty much where I would have let you leave it, except for you probably would have, if you're going to leave it there, you would have kept the radical. Okay. Go up one. Okay. If you were going to leave it there, you would have used, instead of the 1/2, you would have had the radical like that on it, instead of the 1/2. Okay, so let me get rid of that 1/2. So I would have let you do this on the test, so you could avoid having to put these together, but it's really not hard. So I'd like to go ahead and finish the problem. We would need a common denominator. So we would need a 2 top and bottom here. We'd need to multiply by 2 and x plus 2 top and bottom. Over here I have the 2 and the x plus 2, so I just need to multiply by x top and bottom. Okay, and then I wind up with the x squared times the x plus 2. And I really want to see if there's more I need to do, so I'm going to go back to the changing the radical to an exponent. So here I have a 2 times an x. Oh, let's go ahead and distribute, because I got my common denominator here of 2x, x plus 2 in the denominator. So let me go ahead and just distribute the 2 and get 2x plus 4. So I'm doing this part right here, right? Plus another x, okay? So that's 3x plus 4 here over this 2x, x plus 2. And you have to be a little careful because of this being that 1/2 outside there. So if we didn't do it earlier, we would need to think about it now. That 1/2 is outside this big group of parentheses. So that means the x squared is raised to the 1/2 power, which would give you x to the first, and the x plus 2 is raised to the 1/2 power as well. Okay, so that's what I've got right now. Okay. So I am noticing that there's this is on top, right? This is like over 1. So am noticing a couple things I can do. This x and that x can go. And then here I have an x plus 2, and I have that here as well. Okay. Now notice the larger exponent is here in the denominator. This is really to the first power. So I can take that x plus 2 to the 1/2, and I can move it to the denominator, and it would be a negative 1/2 power. So that negative 1/2 power and that 1 would wind up leaving you just a positive 1/2 down here. And don't forget that 2 that you would still have down there. Okay, so that winds up equaling 3x plus 4 over 2 times the square root of x plus 2. Okay. Right, and then there was one more on the study guide I wanted to do. Okay. Let's see if we can set up for that. All right, so let's look at 72. Okay, let's get our bearings there. Remember, we can just ignore this. All right, so here we're taking a look. And let's see. They want us to use logarithmic. So we're going to do natural log of y. Over here, I would want to think about how that's really x squared minus 1 over x squared plus 1, all raised to the 1/2 power. That 1/2 applies to both the numerator and the denominator. So you can either go ahead and distribute it, not distribute it, but apply it to both the top and the bottom as you write it here. So like I'm going to do the natural log of this, but I'm really, let me move this down a little bit, but I really do like doing this. I like thinking of this being raised to the 1/2 and this. I can do that anytime I have multiplying or dividing. So since that power was being applied to this quotient, the 1/2 goes to both the top and bottom. Same thing here. Okay, if I had wanted to on this one, since this was a a product that was being raised to a power, was multiplication there, then I can apply that exponent to both. Has to be either times or division for that to be true. If it's adding or subtracting, you can't just apply the exponent. Like here, x plus 2 raised to the 1/2 is not x to the 1/2, 2 to the 1/2. All right, so if you had done that, then at this point you would come in and do the natural log of both sides. All right, so I have x squared minus 1 to the 1/2 and x squared plus 1 raised to the 1/2 power. I'm going to use my log properties to expand this. It was a quotient, so I know I can do the natural log of the numerator minus the natural log of the denominator. And then that 1/2 that we have can be brought down in front of each of those. And we wind up having 1/2 natural log of x squared minus 1 minus 1/2 natural log of x squared plus 1. And we can't do any more with our log properties. That's it. All right, so at this point, I'm ready to now come in and do the derivative. Okay, so now I'm going to do the derivative of the left side. So 1 over y times y prime. Here, bring down the 1/2. Do 1 over x squared minus 1 times the derivative of the inside. Bring down the 1/2, multiply by the derivative of the natural log of x squared plus 1, which is 1 over x squared plus 1 times the derivative of the inside. Okay, clean that up a little bit. So 2's cancel. I get x over x squared minus 1 minus x over x squared plus 1. And over here, I still have that 1 over y times the y prime. Okay, so I want to think about multiplying both sides by y. That knocks out this, and I'm left with the y prime equaling, and then in place of the y, go back to the original problem and put it, except for I'm going to put it with the exponential notation and that idea that we can apply that 1/2 to both. Because, no, let me do it the other way first, because on the test, I'm going to let you just replace with y. So you could come back in like this and then have it at this point. Okay. All right, but it's really, this one's not bad to fully simplify. So what you would really do to fully simplify it is you'd remember that this is really to the 1/2 power top and bottom. Okay, and that you'd need a common denominator here. So you'd have to multiply by the x squared plus 1. Here you'd have to multiply by the x squared minus 1. Okay, then that would give you your common denominator. Okay, I'll just leave it red. Okay, so that would be the x squared minus 1 times the x squared plus 1 down there. This is the times in between. So on top, I'm going to go ahead and distribute the x and get x to the third plus x. And then don't forget, this is a minus x that's getting distributed here. So that'd be minus x to the third. Then negative x times negative x would be positive. I said it wrong. Negative x times negative 1 would be positive x. Okay. All right, so that's what I got here now. So here, the x cubes cancel, and I wind up with a 2x on top. And then I have the x squared minus 1, x squared plus 1 on the bottom. And I have an x squared minus 1, x squared plus 1 over here. So I have to see how to consolidate those. Okay. So what I can do is this one's on top, this one's on the bottom to the first power. So I can bring that x squared minus 1 to the 1/2 down, which would make it a negative 1/2. So that would turn maybe I'll show you that. I didn't show you that on the other one, but I can bring that x squared minus 1 to the denominator. And then, I already had an x squared minus 1 to the first. And then the x squared plus 1 already was in the denominator. And so was the x squared plus 1. So when you're looking at this, these have the same base. So I really get x squared minus 1 to the 1/2. Then these have the same base, and that's an understood exponent of 1 on that last factor. So that would be x squared plus 1 to the 3/2. Okay, so that would be 2x over square root of x squared minus 1, and then square root of x squared plus 1, but it would be to the 3rd power. Okay. All right,